Time to talk about Avogadro's law. The general idea of this law is that the volume of a gas at a constant temperature and constant pressure is directly proportional to the number of moles of gas. This means the volume of a gas increases with increasing number of moles and vice versa. As more moles of a gas are placed into a container, if conditions of temperature and pressure are to remain the same, the gas must occupy a larger volume. Avogadro's law allows us to calculate a new volume or number of moles by applying the simple relationship below. The relationship between volume of gas and moles of gas is a constant. So if the number of moles of gas increases, the volume of the container will also increase. This is a direct relationship. So again, if the number of moles of gas increases, the volume of the container will also increase. We can see this in the relationship of V1 to N1 is equal to V2 to N2. And one thing to note here is that N means moles. So if you see the symbol N, that represents moles of something. So if I add moles of gas to this chamber, the chamber automatically expands to accommodate an increased number of gas molecules. This, in essence, is Avogadro's law. Let's look at two examples of Avogadro's law. If the initial volume of a gas is 6.89 liters with 0.663 moles, what would the new number of moles of the gas be in 5.26 liters? Let's start out by writing our formula. So V1 over N1 is equal to V2 over N2. My initial volume is 6.89 liters, and my initial number of moles is 0.663 moles. We're looking for the new number of moles of the gas if the new volume is 5.26 liters, so we are going to solve for N2. So if we cross multiply and divide by 6.89 liters, we find that the new number of moles would be 0.506 moles of gas. Let's look at another example. If the end volume of a gas is 1.82 liters with 0.1 moles of the gas, what would the original number of moles be in 6,860 milliliters? Now we have to be really careful here because we know our units of volume must be the same. So either I have to convert liters into milliliters or milliliters into liters. And I believe I will be converting everything into liters. So I'm going to write my formula. V1 over N1 is equal to V2 over N2. So we're solving for the original numbers of moles. So my unknown is N1. My original volume, if I change that into liters, is 6.86 liters. My end volume is 1.82 liters, and my end number of moles is 0.100 moles. So again, if I cross multiply and solve for N1, I find that N1 is equal to 0.377 moles. Like the previous gas formula, this is a direct relationship. As the number of moles increase, the volume should increase. So if we look here, my end volume is 1.82. My original volume is 6.86 liters. So if I'm working backwards here, my moles of gas should be larger. And I see that by looking at my answer, my number of moles of gas is 0.377 moles. That is much larger than my final mole of gas, which is 0.100 moles. And this is a brief example of Avogadro's law.